Next, we want to look at graphs that involve vertical translations and phase shift. Let's look at our first problem. Here we want to graph y equal 3 minus sine x, and I'm going to think of this as 3 plus a negative sine x. So up here I've drawn the graph of y equals sine x, so the graph of y equal negative sine x will look like this. It will just be reflected about the x-axis. Whoops, see if I can get that a little bit better. Okay. Now, 3 plus that graph is just that graph moved up 3 units. So where it's 0 now, it's going to be 3, because 0 plus 3 is 3. Where it's negative 1 now, negative 1 plus 3 is going to be 2. And where it's 0, again, it's going to be 3. And where it's 1 now, it's going to be 4. And again, when it's 0, it's going to be 0. So what happens when I take the graph of y equals sine x, reflect it, I get the graph of y equal negative sine x, and when I add 3 to that, I just take the blue graph and move it up 3 units everywhere. So I'm going to get a graph that looks like this. So there's one complete cycle of the graph of y equal 3 minus sine x. Seems pretty easy. Let's take a look at another one. Here we have y equal 4 plus 4 sine 2x. Let's take a look at this part of the graph and see if we can identify the amplitude and period. First of all, I see that the amplitude for that is going to be equal to 4, and the period is going to be 2 pi divided by 2, which will just give me pi. So I can see here on the y-axis I can label, I've already labeled these 2, 4, 6, 8, so I've got that. Let's label the x-axis, so the period is going to be pi, so I'll make that pi. That will be pi over 2. This will be then pi over 4, and this will be 3/4 pi, or 3 pi over 4. So let's graph one complete cycle of that graph. It's going to start at 0, go up to 1, come back down to 0, go down to negative 4, and then back up to 0. And it's a sine curve, so it looks like this. So there's the graph of y equal 4 sine 2x. Now what I want to do is add 4 to each one of the points on that graph. So where this graph is 0, when I add 4, I'll get 4. Where this graph is 4, when I add 4, I'll get 8. Again, when it's 0, I add 4 and I get 4. Here I have negative 4, and when I add 4 to that, I get 0. And at 0, again, it's 4. So when I add 4 to that graph, I get this graph. So here is the graph of y equal 4 plus 4 sine 2x, amplitude 4, period of pi, and it has a vertical translation of 4 units. Now next I want to play a tape for you that I did a few years ago that involves amplitude, period, and phase shift. Let's take a look at that. We want to add phase shift to the properties of the graphs of our trigonometric functions, and let's look at our first example. We want to graph y equals the sine of x plus pi over 4. And I've written down here the graph of y equals sine x, so we can compare this curve right here, with the graph of y equals sine x plus pi over 4. So you might just ask yourself here, what would it take in here to make that 0? Because I know that when I have 0 right here, the sine of 0 is 0, and that's kind of like where the graph starts. So if I say, well, what will make this expression 0? The answer is negative pi over 4, and that also is the phase shift for this graph. Phase shift is equal to negative pi over 4. So where my graph would normally start right here, this graph is going to start at pi over 4. So all of these points on the graph are going to be backed up pi over 4 units. So where that was right there, it's going to be back pi over 4, and where that was right there, it'll be back pi over 4. So my graph is going to look like this. And some people like to say, well, the graph of y equal x plus pi over 4 leads the graph of y equals sine x by pi over 4 units. So you can see the phase shift right here, negative pi over 4. The graph starts at 0, the sine curve starts at 0 at negative pi over 4 and then goes through one complete cycle. One complete cycle hasn't changed, it's still 2 pi units. Let's try another one. Y equal negative cosine 2x plus pi over 2. So the negative sign here tells me that the graph is reflected. This coefficient right here, 1, tells me that the amplitude is 1. This coefficient tells me that the period is going to be 2 pi divided by 2, which is pi. And then the combination of this coefficient and this constant term right here will give me the phase shift. So my phase shift is going to be the opposite of this number, pi over 2, divided by this number 2. So pi over 2 divided by 2, that's going to be negative pi over 4. So my graph is going to start at the phase shift, which is negative pi over 4. It will end pi units later. So it will end at negative pi over 4 plus pi. So negative 1 pi over 4 plus 4 pi over 4 is going to be 3 pi over 4. So let's see. It's going to have an amplitude of 1, so I'll just make this 1 and this negative 1 on the y-axis. It's going to start at negative pi over 4, so let's put that right there, negative pi over 4. It will end at 3 pi over 4, which is pi units after where it starts, negative pi over 4. So if this is 1 pi over 4, then this is 1, 2, 3 pi over 4. So that's 3 pi over 4. This is 2 pi over 4, which is pi over 2, and this is just going to be pi over 4. So let's see, I have a cosine curve. It's reflected, so instead of starting at 1, it's going to start down here at negative 1. It's going to go through one complete cycle in pi units, so I'm going to go from 1 to 0, from negative 1 to 0 to 1, back down to 0, and then down to negative 1. So I should get a curve that looks like this, something like this. This is a nice cosine curve. Has an amplitude of 1. It has a period of pi units on the x-axis. It has a phase shift of negative pi over 4, and the graph's reflected about the x-axis. So put all those things together, really pretty easy way to graph this fairly complicated looking function just by knowing what these two coefficients do and then that constant term also. Let's try one more. Y equal 4 cosine 2x minus pi over 2. Okay, I have an amplitude of 4. I have a period of 2 pi divided by 2. That's that coefficient there, which is pi. And then I have a phase shift of negative pi over 2 divided by 2. So it's negative c over b. So I have negative pi over 2 over 2. That comes out to be positive pi over 4. So I'll put all those things together, and I'm going to say my graph will start at pi over 4. It will end pi units later at pi over 4 plus pi, which is 1 pi over 4 plus 4 pi over 4, or 5 pi over 4. So let's see, I'm going to go in units of pi over 4, so let's say 1, 2, 3, 4, 5. 5 pi over 4, 1 pi over 4. If I want to know what point is halfway between, I will average these two, so I'll add them together. Pi over 4 plus 5 pi over 4 is 6 pi over 4, and divide that in half. So this will be 3 pi over 4. 1 pi over 4, 2 pi over 4, so that's pi over 2. 3 pi over 4, 4 pi over 4, which is pi, and then 5 pi over 4. Okay, the amplitude is 4, so I'll make that 4 on the y-axis and that negative 4. Let's see, again I have a cosine curve. It's not reflected, so it's going to start at the phase shift of pi over 4. Regular cosine curve starts at 1, goes down to 0, down to negative 1, back up to 0, and then up to 1. So my curve is going to look like this. Nice cosine curve. One complete cycle goes through, it takes pi units on the x-axis to go through one complete cycle, has an amplitude of 4, has a phase shift of pi over 4. Now if I wanted to extend this graph in either direction, it would be very easy to do that. I could just come back here like this, come down like this, and I can extend that graph as far as I want in either direction. Once I have one complete cycle, I have as many cycles as I want. So that's a look at amplitude, period, and phase shift. All right, here we have another problem that we want to do. We want to graph 1 plus sine 2x minus pi. So I've written here that the amplitude must be 1 for this part of the graph right here. And then to find the period and the phase shift, I'm going to do it a little differently this time. I'm going to factor a 2 out of each of these two terms. So when I do that, I have sine of 2 times the quantity x minus pi over 2. Now when the equation is in this form, the number you're looking at right here is what you divide 2 pi by in order to get the period, and this number happens to be the phase shift. So we're in good shape. This one right here is going to give us a vertical translation of 1 unit. Now what I want to do with this graph is to take a look and see if I can get a little bit more information about where this one cycle is going to take place, because I've got this phase shift and some other things going on. So what I'm going to do is take the argument of this function and see what x does as that argument goes from 0 to pi. So I'm going to solve a little inequality. Let's take a look at that. So I'm going to go up over here and write 0 less than or equal to 2x minus pi less than or equal to 2 pi. And looks like I've run off the board. Hang on just a second, I'm going to move the camera. Okay, there we go. That looks a little bit better. Alright, so now I've got this inequality right here. I want to solve this for x. I'm going to add pi to each three members to start with. Pi less than or equal to 2x less than or equal to 3 pi. And now I divide each of the three members by 2, and I have pi over 2 less than or equal to x less than or equal to 3 pi over 2. Okay, so what that tells me is this. As x goes from pi over 2 to 3 pi over 2, this graph is going to run through one complete cycle. So that's going to help me draw my little box and help me do the graphing here. So let's go down here and label the axes. I want to go from pi over 2 to 3 pi over 2. So if I call this pi over 2, and then I go the same distance, that's 2 pi over 2, or just pi, go that distance again, that'll be 3 pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, so my graph is going to take place between here and here. At least I know that one complete cycle of that graph will take place between there and there. Now normally if I was just looking at this part of the graph, the amplitude would be between 1, the amplitude would be 1, so the graph would go between -1 and 1, but here I've added on a 1 for a vertical translation, so that's going to move everything up 1 unit. So if I go over here and draw in this little box, I'll see what you think about this. Isn't this little box here where my graph is going to go through one complete cycle? Let's see, we have a sine curve, so the sine curve is going to start here, it's going to go up here, back down here, and then back up here. So it should look something like this. There's one complete cycle of that graph, and it lies in this box right here, and we found where this box is on the x-axis by solving this little inequality right here, and then we found how it is on the y-axis by just noticing right here that we have a translation of 1 unit up. Let's work one more problem. Okay, we have another one of these to graph. We have -2 plus 3 cosine of all this. I've done a little bit of work on it already here. I factored a 1/2 out of these two terms. When I do that, I get 1/2 times x for that first term, and then when I factor a 1/2 from this, I get 2 pi over 3. Now, one way to check this is just to multiply 1/2 times 2 pi over 3, make sure that you get the pi over 3. Of course you do, because the 2's will divide out when you multiply. So when I write it in this form, though, then it's easier to identify some of the characteristics of this graph. So for instance, I'm going to have a vertical translation down 2 units for all the points on this graph right here. I'm going to have an amplitude of 3. I'm going to have a period of 2 pi divided by 1/2. Which is 4 pi. That's from that number right there. And then I'm going to have a phase shift of 2 pi over 3. So phase shift equals 2 pi over 3. Okay, so I have all the information that I need to know. This graph is going to start at 2 pi over 3, so I could maybe call that 2 pi over 3. But let's get a better idea of what the interval on the x-axis is going to look like by taking the argument of this function, putting it between 0 and 2 pi, and then seeing where x ranges in that in values inside there. So what I'm going to do is go up here, let me get my blue one, and I'm going to say 0 less than or equal to 1/2 x minus pi over 3 less than or equal to 2 pi. Okay, so when I do that, then I'm going to start by adding pi over 3 to all three members right here. So pi over 3 less than or equal to 1/2 x less than or equal to, when I add pi over 3 here, let's see, 2 pi, that's 6 pi over 3 plus another pi over 3, that'll be 7 pi over 3. Okay, then when I multiply all three members here by 2, let's just take it down over here, I'm going to get an interval of 2 pi over 3 less than or equal to x less than or equal to 14 pi over 3. So here's the interval over which, on the x-axis, I'll get one complete cycle of this graph. Okay, let's go to our coordinate system and see what we can do. I think I'll start with 2 pi over 3, that'll be right here. That's where this graph is going to start because it has a phase shift of 2 pi over 3. All right, let's see what happens now. I need to label this a little bit. I need to get out to 14 pi over 3, so let's just count. 2 pi over 3, 4 pi over 3, 6 pi over 3, 8, 10, 12. I didn't go quite far enough here. Let me extend my axis, and I'll end up right there. That looks about right. 14 pi over 3. So I know I'm going to start at 2 pi over 3. I want my graph to be relatively accurate. No, it doesn't have to be great, but just relatively accurate. So if I call this 2 pi over 3, then I just want to count out to where I get to 14 pi over 3. So 2, 4, 6, 8, 10, 12, 14 pi over 3. Okay, normally my graph with an amplitude of 3 would go up to 1, 2, 3, and down to -3. But this one has a -2 added to everything, so where it was 3, now it's going to be down 2 below that, and where it was -3, it's going to be down 2 below that. So -5 and +1 right here. Okay, so that should give me a little box to work with where I can put the graph when I eventually get to that point. So let's just see, I'm going to just draw a little dotted thing in here, come down here to -5, go over, maybe cut this in half a little bit. Let's see, -5 and 1, that difference is 6, so maybe right here. And then kind of in the middle of all this, 1, 2, 3, 4, 5, 6, so yeah, maybe right here. That should be in the middle. Okay, so now my graph should start, what is it right here? A cosine curve, so it should start up here. Okay, go down to here, all the way down right here, halfway up right here, and then back up. Let's see, is that about right? Let me move this one over. Okay, so I get a cosine curve. It's going to look something like this. That looks like it has a phase shift of 2 pi over 3. 2 pi over 3 out to 14 pi over 3. That's a period of 4 pi, right? 14 pi over 3 minus 2 pi over 3 is 12 pi over 3. 12 pi over 3 is 4 pi. Okay, so I got the period right. The amplitude looks like it's 3, because I go up and down 3. And about the only thing left to do would be to label these points on the x-axis. Well, I can average 14 pi over 3 and 2 pi over 3. That's 16 pi over 3. So if I add those two together, this point right here must be 8 pi over 3. 2 pi over 3 plus 8 pi over 3, 10 pi over 3. Half of that's going to be 5 pi over 3. So this point is going to be 5 pi over 3. 8 pi over 3 plus 14 pi over 3, 22 pi over 3. Half of that is going to be, what, 11 pi over 3? So that's this. Okay, kind of sloppy. It's hard to do on this board with these pens and stuff, but in any case, okay, here's our original equation. All of these numbers right here tell us something about the graph. So that's going to be a vertical translation. That's the amplitude. This number right here, if I divide it into 2 pi, I end up with the period. Now I have to worry about the phase shift. A couple ways to do it. You can take this number divided by this number, that's the phase shift, or you can factor a 1/2, this coefficient, out of each term, and then you'll be looking at the phase shift. Now, that gives us all the information, but sometimes it's kind of hard to see where that one cycle is going to be. Easiest way to do that, take your argument for your original function, put it between 0 and 2 pi, solve that for x, and that will tell you the place on the x-axis, the little interval on the x-axis through which your graph is going to go through one complete cycle. Okay, so it takes a while to get to this point right here. Practice, practice, practice. That's the best thing you can do.